Welcome to Star Chat, the cosmic journey that brings us closer to the wonders of the universe. I'm your host, Carl, and I'm thrilled to share with you a fascinating story that's out of this world, literally. Today, we're going to talk about a revolutionary idea that could potentially save our planet from the threat of asteroids. Imagine a huge magnet orbiting an asteroid, gently pulling it apart and diverting its course away from Earth. This concept, called non-contact orbital velocity adjustment, or NOVA, is the brainchild of Gunther Kletschka at the University of Alaska Fairbanks. As we ponder the vastness of space, with billions of asteroids hurtling through the void, it's a reminder that our planet is just one tiny dot in the grand scheme. But what if I told you that this magnet-based technology could be the key to protecting our home from potential threats? The idea is to use a large magnet, about 20 meters in diameter, powered by a nuclear fission reactor, to slowly pull rocks from an asteroid's rubble pile and capture them in a magnetic trap. Each fragment collected would increase the mass and magnetic field of the spacecraft, making it easier to extract the next piece. The implications are staggering. We could essentially shrink the asteroid and move it while turning the spacecraft into a second, controllable asteroid. The calculations suggest that this electromagnetic deflection is plausible. But as with any groundbreaking idea, there are uncertainties. We don't know exactly how much iron is in the target asteroid, and maneuvering a spacecraft so close to an asteroid for an extended period would be a daunting task. As we explore the frontiers of space, it's essential to remember that our actions have consequences not just for our planet, but for the entire cosmos. The pursuit of knowledge and innovation is a double-edged sword. It can bring us immense benefits, but also poses risks that we must carefully consider. So, as we delve into the mysteries of the universe, let's do so with a sense of wonder, curiosity, and responsibility. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat. As we continue our journey through the vast expanse of the universe, we find ourselves in the midst of a fascinating discovery that sheds light on the earliest moments of cosmic history. In an ancient dwarf galaxy on the outskirts of the Milky Way, astronomers have stumbled upon one of the most chemically primitive stars ever seen, Pii 503. This remarkable star is a window into the past, preserving chemical traces from the very first stars in the cosmos. Located in an ultrafaint dwarf galaxy, Pii 503 is the first unambiguous second-generation star found in such a galaxy, providing a unique glimpse into how these stars formed during the initial chemical enrichment of the universe. With its extreme lack of heavy elements, this star is a relic from a bygone era, a remnant of a time when the universe was still in its infancy. The discovery of Pii 503 is a testament to the power of modern astronomy, which has allowed us to uncover secrets that were previously hidden from us. By analyzing the chemical composition of this star, scientists have gained valuable insights into the formation of the first stars and galaxies. The presence of low abundances of iron and calcium, combined with a relatively high level of carbon, suggests that Pii 503 formed from material produced in just one supernova, placing it near the beginning of the second generation of stars. As we delve deeper into the mysteries of Pii 503, we begin to unravel the story of the early universe. The dearth of iron and calcium in this star indicates that it probably formed from material produced in a relatively low-energy supernova, which ejected outer layers of lighter elements such as carbon, while heavier elements collapsed back into the star's core. This chemical signature supports theories about the nature of the first supernovas and the formation of the first small galaxies. The discovery of Pii 503 also highlights the importance of ultrafaint dwarf galaxies in our understanding of the early universe. These tiny galaxies are thought to be analogous to some of the first galaxies that formed in the universe, providing a unique window into the past. As new telescopes come online, astronomers expect to discover more small, ancient galaxies that contain second-generation stars like Pii 503, which will help us develop a clearer picture of the early chemical enrichment of the universe. As we continue to explore the vast expanse of the cosmos, we are reminded of the awe-inspiring complexity and beauty of the universe. The story of PIC-II 503 is a testament to human curiosity and the power of scientific inquiry, which has allowed us to uncover secrets that were previously hidden from us. Welcome back to Star Chat. We've got one last story to share with you before we wrap up today's show. It's been a wild ride in the world of space exploration, and we're excited to dive into the latest updates. First off, NASA's Artemis. The second rocket is back on the launch pad after some repairs, and it's looking good for a launch on April 1st. The mission will send 4 astronauts on a journey around the moon, marking a major milestone in the Artemis program. In other news, United Launch Alliance's Vulcan rocket is facing yet another setback, with the U.S. Space Force transferring a critical GPS satellite launch to SpaceX's Falcon 9 rocket. This is the 4th time in over a year that ULA has been unable to meet its commitments, raising questions about the company's reliability. On a more explosive note, NASA engineers are literally blowing up models of methane-fueled rockets to better understand the hazards associated with these new engines. It's all part of an effort to improve range safety and minimize disruptions to launch operations. Finally, we've got some exciting launches coming up in the next few days, including an Electron rocket from Rocket Lab and an Atlas V from ULA. Be sure to tune in for those. That's all for today's Star Chat. Remember to like, share, and subscribe. And until next time, remember to keep looking up at the stars.